This conference will now be recorded.
So yesterday we discussed about one of the component of Unit 4, that's the process management, and we discussed what the process about the data structure that are concerned with that process, how to conceptually different areas of memories which are allocated to a process. Then we discussed the various areas like code, initialized data, zero initialized data, heap, and stack. What does you mean by the code section, that is called your text segment? What do you mean by initializing data, where your initialization that is also called as your data segment? Then what do you mean by zero initializing of your data? Then what your heap memory consists of, that is also called a dynamic memory, and that grows upward. Then what do you mean by a stack memory? Local variables all being declared, and that is a fixed in size and is being allocated fixed before the process starts. So only the heap memory will grow during the process, otherwise stack memory will remain the same. Then we have discussed so far about the processes, various processes which the various stages of the processes which the process has to undergone. For example, one is ready, one is executing phase, one is suspending or awaiting phase, one is your stop, and one is your termination, that the process has been ended. So these are the various stages of the process. Then process creation phases, we have discussed how to create your process, how to execute your process, and the wait. So these are all your system call, and that makes the process either fork, create a new processes from the parent to child, or after forking, execution will take place. If the process is ready to run, then execution will take place. And if the process is waiting for any resource, any file, then it goes to a suspension or a waiting queue, and that is called as your wait. So these are basically three system calls. Then I've discussed about the parent PID example of forking. That is the example of PID and how to create and how the fork execute. After forking, the PID will get some value, and you have to check whether it's a child or whether it's a parent or forking has been done or not. Then I've discussed about the various commands of process like PS command with the option kill all. To kill all the processes, then kill all is a command. Otherwise, the normal is your kill. To kill one process, then you specify the PID number that you want to explicitly kill that process, then kill or PID. If you want to kill all the processes, you write kill all. You can explicitly mention multiple process IDs also, or if you don't want, then automatically all will be killed. Then PS will show you process status, about the PID number, about the processes which already been running or already been executed, and various options. Right, so these are the various things we have discussed. Then we discussed about the top command that tells you about the resource management or health of the CPU, that what actually the CPU is doing, how much memory is being utilized or unutilized, what are the background processes, foreground jobs or users are how many there, and what are their processes, how many users are using what amount of CPU. That is all about your top command. Then these are the types of processes we have discussed: interactive processes, automatic processes, and daemons. Daemons are the processes which wait for your background processes which are running and sitting idly and wait for your processes or command to be executed. Automatic, obviously, that means obviously the first in first out that followed, and it will run. according to the queue process or spooler. And interactive processes are your processes in which user interact with the shell and executes the command. Then various types of IPC mechanisms we have discussed, how the processes will communicate with each other, like pipes. Through pipes they communicate, through FIFOs, policy mechanisms, through signals, through your short messages, that is called message queues, semaphores, and your shared memories. We have discussed so far this one also, shared memories, map memories, pipes, FIFOs, and sockets. For networking and for hardware level, we discussed about the sockets. Otherwise, these are the software related, like pipes are the through programming, shared memories and map memory, that is also a part of our operating system, and that will discuss about the inter-process communication. Pipes we have discussed that one command output goes to an other command. The communication channel that is unidirectional, and that is more of the two connected commands or two connected processors. So these are the relevant into one single. These are two threads in a single process or between your parent and child. So this is an example of pipe forking, parent forking, then becomes your child, and then your command of child goes to your parent. Similarly, these are the various systems called associated with the pipe, read and write. The name pipe we already discussed. Then please unmute yourself, everyone. Then this is a name pipe for communication between unrelated processes. When two processes are unrelated, then go for your fine. And then your next one is this is about the FIFO. The system called with the FIFOs are open, read, and write. Open your FIFO, that is your channel, and read and then write. So these are then the system call that's with your FIFO. Like command, you are reading the input and you are taking the from the file, that is your temporary folder, and the FIFO. And writing to a FIFO, you are using the cat command, that is for the outputting, and that is for the inputting. That is the outputting to your temp FIFO. So you're writing the commands for removing. Similarly, two use of FIFO, mostly FIFOs are used for client server applications and the shell commands. The signals I have discussed about that. Signals are the in between the messages to control the processes, to send signals directly from the OS or from hardware recon event to occur between a bus, to send the messages from one process to another, that what is going to be happen if anything. Similarly, each signals can be defined to 5 classes. It can be a hardware signal, a software input output, or any process control and resource. Similarly, kills signals, your list of set of signals using the kill command. You want to kill any process that is in the waiting state or suspension state, or any kind of signals can be used to kill the process also. Similarly, signals can be discarded, signals can be terminating, and it can be choose to implement. Signals implements, Linux actually implements the signals using information stored in the task structures. So everything's stored in the task structures of the process, currently pending signals. Fine, so everything is there, and one more data structure that maintain the signal is called as your sig action. How to send signals? There are two things. One, to kill the signal, and every signal has a PID number. Every signal has an integer number. So one is your PID number and one is your integer number for the signal. You can kill the signal and you can raise or generate your own signal also by raising a signal number. So signals can be generated. Similarly, message queue, message sending and message receiving. The topic which has to be discussed today is your memory management. So memory management refers to the mechanisms. It actually refers to as your mechanisms implemented by operating systems to operate in by your operating systems to provide applications with memory related services. All your services by your memory, from your memory, or user memory, that is all defined by your memory management. These services include the usage of virtual memory, either your hard disk or your RAM or any kind of memory, protected memory, shared memory. So all can be managed by your memory management. System never allocates any physical memory directly. Each process has its own virtual view of memory. The process thing is the only task running on the system, and virtual memory is then mapped to your physical memory using the page tables. So memory can be, all information is maintained in the form of your page table, and later on virtual memory is allocated with your physical memory. So each process has own memory to run to execute that process. This is the diagram of your virtual memory. This is your shell which is running. This is the page table mapping, all the mapping of the page table, that is from your virtual memory to your bash and to your physical memory. So page table is actually doing the mapping of your virtual memory to your physical memory. You already been told in your operating system or studied in your operating system about fragmentation, segmentation. So these are all concept of operating systems. So mapping, all the mapping is maintained in your page table. So basic unit of memory is, as I said, the basic. You have to mute everyone, then it's okay for. So the basic unit of memory is nothing but your page, that is the non-overlapping region of contiguous memory, and all available physical memories are organized into a pages towards the end of the kernel boot process. Traditional memory pages just sizes your 4096 bytes. It has few Linux systems have allocated and releasing the memory split into three layers. So in Linux, the memory management is divided into three layers. One is your slab allocator, one is your zone allocator, and one is your buddy allocator. Fine. So in three phases, these memories has been divided. We have the just a gist of these. That what you mean by your. So first one is your slab allocator, or first one is your buddy allocator. So buddy allocator splits the memory into two pairs of pages and stores the information in the form of list. The contiguous physical contiguous blocks of memory. It has every order has a block. So buddy is nothing but dividing the memory according to their order number, and each block has its own ID, and they are very close to each other. That is why these neighboring blocks are called as your buddies. These neighboring blocks are called as your buddies. On the other hand, every two blocks of memory the same size having the common border and may be united into a single block of the bigger size, and that is why these are called as buddies. So when allocation is returned to the buddy allocator, it checks if the buddy of the allocation is free or not. So buddy allocator unites them into a bigger block. If one block and second block is free and second one requires more allocation or more space, then it go for the buddy allocation. So to make one block and merge it into a bigger block by sharing a border, then this allocation is called as your buddy allocation. It's the fast and simple. It avoid any external fragmentation. This is the advantage of buddy. Advantages that you cannot You cannot go for internal fragmentation. Right? So two borders can be joined and two bodies can be joined together, but you cannot go for internal fragmentation. In between the blocks, you cannot go. So it can be go for fragmentation and behind merge the two blocks of nearby, but it will not go for the in between the blocks. So if there is any memory left within the block, it cannot be sorted out. But between the two adjacent blocks, it can go for it, but not for 2 and 4 blocks. Only the 2 blocks can be merged out and becomes the, like these 2 blocks can be merged out if they becomes the body and they require more memory to be for the processes. Depends upon that if your next block or body block is available free or not. So this is a body allocator. Similarly, zone allocator, it will divide the kernel into a various zones. So zones can be allocated pages on specific zones. For example, divided into 3 zones. One is DMA, dynamic memory allocation, normal, and high memory. So it can divide into these various zones. Like for example, daily is divided into north zone, south zone. Depends upon that. So dynamic DMA, one is your normal zone, one is your dynamic memory. For example, you want to randomly increase the processes of increase the memory, then it's called as dynamic memory zone, and one is your highly sensitive memory zone, so that is the high memory. Each zone has its own allocated and unallocated physical memory, base address, number of frames, area of frames. So each zone equipped with a body system that facilitate effective allocation of the power of two size blocks of the frame. So each zone is having his own body system, and they can associate and they can increase the size depends upon the capacity and the process requirements. System calls for the frame allocation. These are system calls for a zone allocation, that is a frame and your frame free. So one is your alloc and one is your free. Allocation of the memory, your frame is divided the physical memory into various frames. So you want to allocate, you want to acquire, then the process is called frame allocation. Otherwise, you want to free or the process had been terminated or go stopped, then it's called a frame free. Then the last one is your slab allocator. So slab allocators oftenly having the objects having less size. We need something to deal with pages and allocate lesser chunk of memory, then we go for the slab allocator. Fine. So slab allocator is an object caching kernel memory allocation. So it keeps on switching between the memory pages of small processes. Like for example, number of small processes are running before the process, after the process, foregrounds and background jobs are also there. So these are all managed by your slab allocator. This means constructor of the object is used only the new allocated slabs. One should initialize the object before releasing it to the slab allocator. So slab allocator is dealing with the all smaller chunks of the memory. Fine. How to release it, when to release it, ongoing, ingoing details, meta information. So all the smaller chunks is maintained by your slab allocator. Slab allocator organizes memory in caches, one cache for each object. Each cache consists of many slabs, and each slabs contain multiple initialize. Basically, it deals with your initialization process, termination, initializations, ingoing, outgoing information. So each begins with your each slab. So that is why this information is maintained in your chunks, in a smaller chunks. Fine. The last topic in the memory allocation is your system calls and your library calls. Already discussed library calls like malloc, alloc, reallocation, free. These are all system calls related to memory. Dynamic allocation can be done by malloc or calloc. These functions return the pointed allocators to your memories. You have read in C, calloc, malloc, everything. Once you have a block of memory for a certain initial size, you can change its size with reallocation. You want to redefine its size, then go for realloc. If you want to release the memory, then go for free. These are the various library functions. In this way, you can define the pointers. This is the return type because the pointer, so they are returning only the addresses. These are the size. This is all about the discussing about the pointers and their memory sizes. So release, allocate the new size. What is the new size? Allocate and zero fills, changing the size, reallocation to a new size. So these are all your system calls with their return type and with their parameter arguments. Initializing, allocating memory using the malloc and the size. This is the return value of the pointer is newly allocated is either a null. When you allocate, it will return the address of the, otherwise it's returning null. That is why it's a void. When the size is given and then the function is called, this pointer will return the base address of your process. The base address, where the memory.
130 करोड़ का देश है हमारा, कितना 130, हम कोई जर्मनी इटली फ्रांस नहीं है, इतने इतने देश है जर्मनी इटली, ये जर्मनी को तुम
My God. Everyone please mute before entering the session, please everyone mute. Fine, so these are this is the function of your system call. It will return and it will return the pointer's address. The second one is your free. When you want to release the memory, this is the pointer and this is the function of system call. It will return the pointer's address. Similarly, reallocation. These are the few steps for the reallocation. It will change the size dynamically. It can possibly shrink the block of memory if the block is grown too much, and changing the handles with your, you can change the size dynamically by reallocation. Okay, lock is for, obviously it is adding, it's actually allocation. The new allocation can be done. Fine. These are the few systems called BRK and SPRK. That is actually your breaking. That means you want to have a system call actually change the process address space. If you want to put a break or you want to pointing somebody else memory space or do you want to move the process, then you go for BRK systems call. Is a logical address representing the end area of your end address space. So it will return. So it will return 0 or -1. So these are the other system call. For when system break is there, you want to increase or decrease is there, process data. Fine. So these are the few systems call related with your memory management: Kellogg, free, read, open, write, allocation. So these are the library calls which deals with your memory management. So read it out, this one about this is all theory, that how to deal with that, memory zones, body allocator, zone allocator, and your slab allocator. These are the various things to be discussed in your memory management. Fine. Then another one.
This conference will now be recorded.
Fine. So this is actually the slides of few programming. So I've discussed this one, just shell programming. Fine. Ashish, please mute your mic and don't open the mic, right? Otherwise, I make you out of the session if your now mic opened up. Are you getting me, Ashish? So the shell programmings, this is what you mean by a shell. A few gist of shell programs I want to give it up because the class were very few in number, so I want to give it a few slides over the shell programming. Now, what do you mean by shell scripting? Shell is nothing. Shell script is nothing but a series of commands to be stored in your plain text area. A shell script is similar to the batch of files in MS, but is much more powerful. When you are running the command one by one, that is okay. But if you want to run the set of commands or series of commands one go, then you have to write the shell script. Now, shell scripts is an ordinary file containing a set of commands which is executed in an interpretive manner and also known as a shell program or a shell procedure. You can make a shell file by extension called .sh shell script and a sequence of the commands. For example, this is a command directory. Fine, this is a set of commands you want to go or run in one file. Then you use a file name. There's a file name dot and sh is the extension shell. For example, pwd command, you want to print the today's date, you write echo command, anything on the output console you want, this echo is used. So date and the echo and the current directory with your this. So date is your system defined function. It will print the system date. Fine. And similarly, you want to print the current directory. So current directory, you have used the variable, and that variable you have used a command pwd. Pwd will set the output to your directory, and the current directory is this one. Please unmute your mic, everyone. Ashish. So this is a shell command and this is a shell's procedures, how to write a shell file. Fine. So the next one is your shell program is nothing a series of commands to do this. Is the automatic command execution. It is like the batch processing of commands and your repetitive task. Fine. So shell programming by default, when you start with your shell command, the first line is your hash and this exclamatory mark, which will indicate your starting of the shell. So when you start the shell scripting, it will start with your hash and your exclamatory mark that the script is directly executable. And by default, for example, if it's the by default Bourne shell, then this will be written hash bin, that is your bin and slash your shell. So binary is a folder and sh is that folder that contains all your shells, whether it's the T shell, whether it's your K or whether it's your. What is the problem with your Ashish? Ashish, please mute your mic. What is the problem with the Ashish? Yes, so next one is your. So shell is nothing, but you want to go for the shell version, you can use the command bin /sh and your version. So this is your basically the bash. These are various your shell environment. So this will by default the shells are there, batch shell, CHL, and you want to see the version. This is and by default system folder which contains all the shell and then information, that is your bin/sh. These are the by default Linux shells. So these are the by default shells. Original shell is your Bourne shell. Similarly, K shell with having a more functions added to that. Then your Z shell, then your bash shell, that is your Bourne again shell, and C shell and your TCS shell. So these are the various, their originators, the launchers there, and these are the various, like C shell is written in your C syntax. TC is enhanced version of your C shell. Similarly, Bond again is also a advanced version of your Bond shell. So by default, you will get the bash shell in your Linux environment or your C shell. So these C shell, Bond shell, K shell, these are the three shells you will get by default. Other shells you can add it by yourself. So various variables in your shells, like various variables are there in this. Yes, class, please unmute your mics. Ashish, what is the problem with you? Are you not getting the things right? Or I shall you block for always? Why you are muting your mic, everyone? You're creating a noise in a class. If you don't want to attend the class, you can leave the class. You're creating a mess here in the class. Yes, class. So these are the variables in a class. There are actually two types of variables, system variables and user defined. That user defines are called as your UAV. That is called the user defined variables. And system defines are your environmental variables also, and they're all in capital letters. Similarly, sometimes it's defined as the three types of variables. One is your local variables, which you define an instance of the class. One is your system variables or environmental variables, which are always capital letters. And one is your shell variables. That's for the shell requirements. These are also a part of your system variables. Environmental variables and shell variables are a part of your system variables, and these are your user-defined variables. But in some books, you will get local variables, environmental variables, and your shell variables. So these are the various folders. You will get all the information about the shells in your etc shell folder. Fine. Various valid shells are there, the list of the shells. Similarly, password folders to execute your shell as a root user or any administrator user. Then the password folder to details about the login IDs and their password. Similarly, other functions, log out, exit, control D to move out of your shell file, control D, exit and log out, and chsh to change the shell. For example, you want to change the shell, then you have to use the change sh that defines for your changing the shell. Similarly, similarly defining your decision structures. These are your decision structures like if rules, else rules, and your end if rules. These are your decision structures, if and end rules. Similarly, control structures, if then statements. If statement is closed by your FI statement, like if condition, then the possible set of command, what you want to do by the if command, and then the closure statement, that is your FI. If, then, else, and your FI. Like this is a program. This is the control structure. This is the control structure. For example, the first line of your Ashish, please. Let me. Ashish.